The third property of water that helps it maintain life on our planet is the fact that frozen water, ice, is less dense than liquid water. And again, this is one of those three properties of water that has everything to do with hydrogen bonding. So if you think about most substances, as you cool matter down, it becomes more and more dense, right? The atoms, the molecules start to pack together. The reason for this is the colder the temperature, remember temperature is the average kinetic energy of a body of matter, that means the less thermal energy those atoms and molecules have. So they're vibrating less and less and less, and they can pack together a lot more closely. So most substances, the colder they get, the more dense they get. And this is true for water up to a certain point. As you cool water down, it continues to become more and more dense until you reach 4 degrees Celsius. Now, if you're not entirely familiar with the Celsius scale, freezing in the Celsius scale is 0 degrees. So 4 is just above freezing. At 4 degrees Celsius, this is where water reaches its most dense state. From there, as you continue cooling it down, it actually starts to become less dense. So let's take a look at it. All right, on the bottom of this figure here, in the circle that has a blue background here, you're looking at liquid water. And liquid water, the water molecules, remember, they're sticky. They like to form hydrogen bonds with each other. But the hydrogen bonds form, and then they break, and they form with other water molecules, and then they break as those water molecules are all bouncing around. And so you can see how densely packed these water molecules can be within liquid water. But as that water now goes below 4 degrees Celsius and it starts to freeze into ice, remember, under those conditions where water is frozen to solid ice, each water molecule has the ability to form all 4 of its potential hydrogen bonds. So if you look at the other circle here with the white background, this is an example of what the water molecules in ice would look like. And you can see how each one is now forming 4 hydrogen bonds with water molecules next door. And it kind of holds those water molecules at arm's length, a certain distance apart. It helps to spread them out a little bit. And so in solid water, in ice, the water molecules are actually far less dense than they are in liquid water. Now, you've seen this phenomenon. You take ice cubes, you put into a glass of water, and the ice cubes don't sink to the bottom, right? They float towards the top. This is a good thing for life because imagine here in Texas, our ponds and lakes don't really freeze over, but in Illinois, where I'm from, ponds and lakes freeze over all the time in wintertime. And so imagine if a pond the water on the top would freeze to ice, and if the ice was more dense, then it would sink. And then the top layer would freeze, and then it would sink and freeze and sink until the entire pond or lake would be completely frozen. Life, fish, right, any other organism that lives in that liquid water would not be able to survive through the winter. Instead, though, because ice floats on the surface of water, you form that nice ice crust on the top, and life can still survive underwater just fine through the rest of the winter. So again, it's a really good thing that, in fact, solid water, ice, is less dense than liquid water and it floats on the top.